Before starting this demo, I want to show how we are controlling this robot with the app that I have created through MIT App Inventor 2. As you can see, there is a connect button, forward, left, right, backward, a button for showing distance through ultrasonic sensor, and stop button for stopping the robot. Now I'll show how we can connect it with the Bluetooth that is in the robot. This is the address of the Bluetooth in the robot. We can click on that for pairing with it. Now our app has paired with the robot. Now let's see whether it will work or not. As you can see the robot in the distance. Yeah. Now I'll be clicking the forward button. There it goes. I'm stopping it. Yes. Now I am taking it backward. Stop again. Yeah. Left. Stop. Right. Stop. So this is a very simple app. I will be going through the app, how it is built and in which platform it has been built, and also explaining the code for the Arduino in which we have programmed this robot. Before that, I will show you the components. Now let us take a look at the components. This one, what you see here, it is the motor driver. Below that, out here, below this motor driver, there is this Arduino Uno board, which is basically containing the microcontroller. This is the power bank that powers the motor. These are the two motors and the wheels. These are the sensors, but at this current project it has no use because this is used for the line follower and edge avoider robot, and these ultrasonic sensors are used for the measuring the distance, which is not required right now. The main component right now which we must focus is this one. This is the Bluetooth module which we will be requiring in this project. So before going to the code, I will take you through a brief tour of MIT App Inventor 2. This is the platform where I have developed this simple app, and if you Google MIT App Inventor 2, that will be enough for you to go to this site, log in and create your own app. So this screen which you are seeing right now is called the designer screen. If you can see out here, it is written designer. You can add various components that you want to display on the screen of the phone. For example, this is a connect button. So there are many buttons, checkbox, image, different user interfacing buttons which you can drag and bring out here. For example, I am dragging a button and putting it out here. So this is how I have created these buttons out here: connect, forward, left, right, backward, etc. Right now I am deleting this. Okay, and other than that, basically I'll be concentrating on particularly this app which I have created, and you can see two non-invisible components, Bluetooth client and clock. So if you go to connectivity, here is the Bluetooth client. You can just drag it out here and it will be visible out here. I had dragged this clock button, but at present it is of no use, so I can even delete it. Now once all the buttons are aligned, you can use the layout button to align the buttons. once I placed all my buttons, now I have to give certain functions to it. That is, when I click connect, it should connect with the Bluetooth of the robot. Now when I click forward, the robot should go forward. Now how are we going to do this? Let's look at the blocks. From designer, we are moving to the blocks button. Now we have moved on to the block segment. There are various components out here which are known as blocks, through which we can put the logic of what each button or individual components which we described earlier can do. Now for the Bluetooth client, under this Bluetooth client there are various buttons out here, you can see. We can drag this out here to give it a particular function. So in the designer block, we have dragged a list, let us say list picker. We had dragged a list picker into this designer block, which is appearing under the block button out here as list picker. When you drag this out here, when list 1 that after picking, when list 1 picker, list picker 1 that before picking, you can drag it out here and assign any logic you want. So this is for Bluetooth. This block I have brought out here, and its function is that when you click the connect button, it should display a list of available paired Bluetooth devices. So this block out here, before picking, it displays the available Bluetooth devices. For doing this, we can click on list picker and drag this block out here, and after dragging this button out here, we have a subordinate block or associated block to which it is telling what to do. For example, right now it is telling display the elements of various Bluetooth devices. The next block, which is list picker 1 dot after clicking, it is also available out here, you can see, after picking. To this block, we are, after clicking the particular device with which we want to connect, it will pair that device with the particular app that we have created. This is the Bluetooth connect.address block, which is doing that function, which we can see under Bluetooth client 1. This is that particular button. After that, let's go towards the logic. When button 1 is clicked, so let us see what button 1 is. This button 1 is basically the forward button. So we are giving the logic out here. When button 1 is clicked, then what the app should do, it should call the Bluetooth and it should send a text forward through Bluetooth to the robot. Similarly, when we click button 2, let's see what button 2 is. Button 2 is backward. So when button 2 is clicked, we are calling the Bluetooth and telling it to send text backward. We have the same case with button 3. When we click button 3, which is the left button, if you go to designer, it will call the Bluetooth and tell it to send a text to the robot left. Same with right, and same with stop. There is also one button, button 9. Let's see what it is. Yeah, button 9 is the distance button. So when we click the distance button, it will send a text RS dist to the robot. When the robot receives this text RS dist, it will understand that we are asking it to display the distance between the robot and the object next to it using ultrasonic sensor. After the robot measures the distance, it will send back the measured distance, which we can use to display in the text box 4. This is the text box 4 out here. So it sends the text box for and receives the text from the robot. Now let's see the code. Hash include, this is the header file. So if you are well to do with programming, you know what a header file is. This afmotor.h, this file is actually for the motor shield, the motor driver. It contains all the function for running the motor, for setting the motor speed, for telling it to move in clockwise direction, to rotate in anti-clockwise direction. And it is written by someone else, but we are calling it in this program. This is one of the functions of this header file, af_DC motor. Through this we are declaring a motor variable, telling the program that there are two motors, motor 1 and motor 2, and we are also giving it the operating frequency out here. This is just for declaration and initialization. Now we have to set up some initial speed of motor. For motor 2.set speed, motor 1.set speed 255. This is basically, we are telling the speed, initial speed for initializing the motor speed, and 255, this is the maximum value we can give. So we are telling that motor should run at full speed. In the next line we have motor 1.run release, motor 2.run release. Motor 1.run or motor.run, it is a function of that header file which tells the motor what to do. It can tell it to go forward or backward or release. Release means we are telling the motor to stop. So initially we are initializing the speed, and we are telling when the program runs initially, the robot should be not moving, or it should be in steady state. Once we enter the loop, first we check for any serial information or any input from Bluetooth, whether it is connected to Bluetooth or not. So while serial.available checks whether it is connected to Bluetooth or not, and if it is connected, this whole program cycles. In the next line we have string input is equal to serial.readString. Actually I have already shown you in the MIT App Inventor that we are sending left command, right command, like out here, which we discussed previously. We were sending right string, stop string, to tell robot what to do. So we have to declare a string variable input to read a string from the mobile app which the Bluetooth of mobile is sending. Now we can check the logic with the input, whether what was the input that was sent by the mobile phone, whether it was forward, whether it was backward. If input is equal to forward, then this means we are checking whether the input from the mobile phone, which we read as serial.readString in this line, whether it denotes forward. If it is forward, then we are telling the motor, both the motors, to move in the same forward direction. After that we are delaying by 500 milliseconds. Now again we are going through this program and checking what is the next string that is read. If it is right, then we are stalling one motor and telling another motor to go forward, another motor to go backward. This way the motor turns, or the whole robot turns in the right side. Now if the string that was read was left, we are telling one motor to rotate in back direction and another motor to rotate in forward direction. Similarly, if the input was backward, we are telling both the motors to rotate in backward direction so that the whole robot moves in backward direction. The stop button. If you want to stop the robot, then we are calling motor 1.run release, as explained previously, to stop the robot. Thanks for watching my video. I'll be coming up with some more improvements in my next video, which shall include sliders for motor control in our app, and also voice control robotics using Google Speech Engine. So please subscribe to my videos and stay subscribed.
Thanks.